So we're going to let capital F of x equal the integral from 0 to 2x of cosine t dt. And I want to find capital F prime of x. All right, so if I want to do this, what do I need to do? Integrate. Right. Basically, I'm going to have to integrate that, and then I'm going to have to turn it on and take the derivative. Well, what's the integral of cosine t? It's just sine t, right? Okay, so it's the sine of t evaluated from 0 to 2x. Okay, well, the directions are saying capital F of x equals that integral. And the directions are saying find capital F prime of x. Well, kind of. But let's go through this so that we can see what the pattern is and then not have to go through it every time. How's that? All right, is everybody okay with the integral of cosine being positive sine? Because the derivative of sine is cosine. All right, so this is the sine of t evaluated from 0 to 2x. So which do we plug in first, the top or the bottom? The top. So it would be the sine of 2x minus the sine of 0. And this would equal big F of x. All right, what is the sine of 0? 0. Okay, so big F of x equals the sine of 2x. And I'm looking for big F prime. Okay, it's been a while since we've taken the derivative. What's the derivative of sine 2x? 2 cosine 2x. Okay, so that is what my answer is right here. Fortunately, there is a shortcut, and that is called the second fundamental theorem of calculus. Fortunately, there are only two fundamental theorems of calculus, the first and the second. So we're done with the fundamental theorems of calculus. So fortunately, there's a theorem that allows you to take the derivative of a function that is defined as an integral. Okay, you need to get used to that phrase right there, a function that is defined as an integral. A function that's defined as an integral is a function that says f of x equals the integral of something. Does that make sense? You okay with that? All right. The second fundamental theorem of calculus says that the derivative of the integral from a to x of f of t dt just equals f of x. Now, that looks too simple because that's not exactly what we got there. It's not exactly, this one just happens to be f of x. But what's really going on here is that when you integrate, basically what's really going on here is you plug in the top limit for x, or for t. So you get f of x, and then you have to multiply by the derivative of that top limit. What would the derivative of x be? 1. Minus, plug in the bottom limit for t, so f of a. And in this case, a is a constant, so what would the derivative of a be? 0. Okay, so that's where you get just plain old f of x. So when you're taking the derivative of an integral, you plug in the top times the derivative of the top minus plug in the bottom times the derivative of the bottom. And by the top and the bottom, I'm talking about the limits of integration, the top and the bottom limits of integration.
So is f of x going to, oh wait,
so let's work number 3 to just show you exactly how this works. And this is only for finding the derivative of a function that's defined as an integral. All right, so if I want to find the derivative of capital F that's defined as an integral in number 3, then capital F prime of x is going to equal, I'm going to plug in the top limit for my variable. In this case, it's t. So it would be 2x, and then times, what would 2x the quantity squared be? 4x squared plus 1. Now I have to take the derivative of that top limit of integration, which is 2. Okay, so this part right here is just plug in 2x. And then this is the derivative of the 2x. The 4x came from, if I'm plugging in a 2x, then I have to square the whole quantity 2x. All right, minus, now I'm going to plug in the bottom limit, which is x. So x times x squared plus 1 times the derivative of x, which is 1. Okay. And, you know, if I'm pretty okay with you not simplifying that, if you don't really want to. Although 2x times 2 be 4x. Let's do 4x times 4x squared plus 1 minus x times x squared plus 1. I don't know. If it's a multiple choice question, I probably would have distributed and combined like terms. But for a free response, you really could have stopped at the first step if you really wanted to. Okay, so if you went the long way, the steps would be to distribute your t, integrate, plug in the 2x minus plug in the x, simplify, and then take the derivative. So it really is. Okay. All right, 4, f prime of x. Is that top limit x cubed? Okay. And is the bottom limit pi over 2? Okay. All right, so plugging in the x cubed would be the cosine of x cubed times what? 3x squared. So plug in the x cubed times the derivative of x cubed minus, plug in the bottom, so the cosine of pi over 2 times the derivative of pi over 2, which is 0. So what happens to that, everything after the minus sign? It's gone. So in general, if your bottom limit is a constant, will you ever have anything after the minus sign? No, because if your bottom limit's a constant, you're plugging that number into the function, and then you're multiplying it times the derivative, and the derivative of constant is 0. Okay, try 5 on your own. And since that bottom limit, is that pi over 3 for the bottom limit on number 5? Okay, since that's a constant, we don't have anything after that. On 6, I want you to try 6, and I want you to simplify 6, because there's a question on an upcoming quiz that's very similar to that, and you have to simplify because it's a multiple choice question, and I just want to make sure that you get all your parentheses in there. So try number 6 and simplify it completely, please. And be careful with your notation. You can't just write that this function equals that, because what you're doing is taking the derivative. So you need to write that f prime of x equals whatever you're getting to. Everybody okay? On 7, when you square a quantity, make sure you put it in parentheses. Like when you're plugging the 5x in, you either need to write the quantity, or you either need to write 25x squared or the quantity 5x squared.